An important step in completing a brake service is to check for disc rotor lateral runout. Lateral runout is the primary cause of brake pedal pulsation and brake comebacks, since it leads to disc thickness variations or uneven wearing of the rotor. This video will demonstrate how to measure the rotor lateral runout and, if out of specification, how to correct it. When installing a new or resurfaced rotor, care must be taken to ensure that the combined rotor and hub assembly meet the manufacturer's specification for allowable lateral runout, which in many cases is less than 0.02 of an inch, or 0.1 millimeters. To measure for lateral runout takes about 60 seconds, and all that is needed is a dial indicator and a set of conical washers. To ensure accurate measurements, we highly recommend that you thoroughly clean both of the mating surfaces of the hub and the rotor. A hub cleaning tool makes it easy to clean around each wheel stud. Make sure all areas are free from rust and debris. In this demonstration, we will be installing a high-quality new rotor at meet specifications, but due to the stack tolerances of the hub and rotor, the total runout may still be greater than the allowed specifications. Install a machined or new rotor onto the hub using the vehicle's lug nuts and torque to the manufacturer's specifications. We highly recommend the use of conical washers to ensure the rotor properly seats onto the hub. Attach a dial indicator to a rigid part of the vehicle spindle. Tighten the dial indicator arm in a position where the needle of the gauge contacts the rotor approximately a ½ inch from its outermost diameter. Lift the spring-loaded needle on the gauge up off of the rotor a few times to ensure that the needle is making good contact on the rotor friction surface. Notice how the gauge oscillates back and forth between the high and low points on the rotor. The lowest reading is the lowest point on the rotor. After determining the low spot, rotate the face of the gauge to set 0 at this needle location. Rotate the rotor again to ensure the low spot is exactly at the 0 setting. Continue rotating the rotor to determine the high spot. This is the location of the highest lateral runout. Record this amount. As this vehicle is well in excess of the 0.02 or 0.1 millimeter specification set by the vehicle manufacturer, first try to index the rotor by rotating it on the hub 180 degrees. If this does not correct the problem, use a brake-aligned lateral runout correction plate. Runout greater than 0.006 or 0.15 millimeters means there may be a more serious problem. You will need to determine whether the hub or the rotor is the cause and replace or repair accordingly. The dial indicator shows 0.006 or 0.15 millimeters of lateral runout. Mark the rotor in the exact location of this high spot. Rotate the rotor again and stop the rotation when you reach the highest reading. Where the needle contacts the rotor is the exact location of the high spot. Mark this location on both the rotor and the closest wheel stud. Marking both points is very important. Pivot the dial indicator out of the way. It is helpful to rotate the rotor to bring the high spot to top dead center or at 12 o'clock. Using the brake-align application chart, locate the year and model of the vehicle being serviced. This 2010 Chevrolet Impala will use a BA 80106 correction plate. The 06 in the part number indicates the amount of taper or correction. The hub correction plates are available in 2 increments, 0.003 or 0.075 millimeters, and 0.006 or 0.15 millimeters. Since we have 0.15 millimeters or 0.006 of runout, we will select a BA 80106. Once the correction plate has been selected, remove the rotor. Note the wheel stud that was previously marked on the location of the high spot. On this application, there are 10 holes on the plate that will allow for proper alignment of the plate even in instances when the high spot is in between 2 wheel studs, as it does in this case. The hub correction plate has a V-notch on the inside diameter. Install the correction plate onto the hub, being careful to align the V-notch of the plate so that it falls between 2 studs nearest to the marked wheel stud indicating the high spot. Reinstall the rotor onto its original position on the hub, lining up the markings on the rotor with the marked wheel stud. Using the conical washers, install and hand tighten all of the lug nuts. Next, torque all lug nuts to the manufacturer's specification. Pivot the dial indicator back into position onto the rotor. Turn the rotor clockwise to double check for any lateral runout. The total amount of runout is now well within the manufacturer's specifications. The key point to remember in this situation is that the new rotor we installed was within the manufacturer's specs. The problem was with the hub assembly. We were able to fix the problem easily and cost-effectively with a break-align lateral runout correction plate versus the major expense of replacing the entire hub assembly. Please note, had we not replaced the rotor and not corrected for the lateral runout, the test drive would have been satisfactory, but pulsation would have returned in as little as 3,000 miles or 5,000 kilometers. So the next time you're doing a brake job, to prevent pedal pulsation and brake comebacks, be sure and measure for lateral runout with the proper tools.